Hi there, my name is James O'Connor and I'm a graduate student at Northwestern University, which is in Evanston, Illinois. My primary research interest is in energy, basically the different forms it takes and how we can better utilize it for things in the future, which we all know is a pretty hot commodity. So, how I go about doing this is primarily through the use of something called two-dimensional electronic spectroscopy, or 2DES for short. To put it a little simply, 2DES is basically using the flow of energy to understand how a system behaves. How I go about doing that is by using a pump energy to put energy into a system and then using a probe to see what energy comes out. So the example 2DES spectra on my right can be used to visualize this, where we have a pump and a probe, and then we have all the different energetic absorbances and emissions that come along with it. I could use this map to understand and figure out exactly how energy is behaving within like a molecule or a compound or a film or anything else. Recently, my research project has taken a pretty interesting direction. We're now looking at systems at extremely cold temperatures, temperatures that are around 85 degrees Kelvin, or basically you can think of this as something we need liquid nitrogen to get all the way down to, and is hundreds less the temperature that you usually live at room temperature. So this all sounds fine and dandy, but what was really neat about it was that we had a gigantic kind of cryostat system is what we call it. And so it's a huge cylinder cage with a little tiny sample window at the bottom, which you can probably see in this picture here. And we had to load that into our table and understand exactly if it's at the right temperature, if we're getting enough light through to actually look at the system and things like that. This is all a lot of fun, actually, as it turns out, because you can see the light coming out through the dark and everything once you turn off the lights, and you can also understand a little bit better what it takes to reach these really, really pristine and proper conditions to do a proper experiment. Of course, all of this is easier said than done, especially during the year of 2020 and now coming into 2021. But through the use of mentors and a lot of rigid structures, despite all the other stress that's been going on with daily life, at least I've been able to use research as a kind of focal point to be able to put in my work and effort and also really see a lot of fruits of labor come through. I've made a lot of great friends. I've made a lot of really interesting connections that I wouldn't have thought of before in my research. And so hopefully through doing these things and making more progress, I can see myself moving further into the future into a role of something like a professor or somebody working at an industrial lab in the future. As I move into this far future, though, I'm pretty confident and ecstatic because science and STEM on the whole has been improving right alongside me this entire time. I know for sure that in the future we will see things like STEM education, workshops, and even videos like this being more widely accessible and more readily apparent to those who are able to use them for help. So these resources not only will be able to help me get better in the future, but also help me to be a better educator and help those in my surroundings. Because after all, science almost always comes down to being able to give it to a wider audience and an overall purpose. So, for all those things, I'm always thankful for and always optimistic of the future.